Logger context in Log4j. Now we are focusing on logger context. The logger context acts as the anchor point for the logging system. However, it is possible to have multiple active logger context in an application depending on the circumstances. Here you can see interfaces lifecycle and lifecycle 2. With the lifecycle interface, all proper Java frameworks implement some sort of object lifecycle. In Log4j, the main interface for handling lifecycle context of an object is this one, lifecycle. An object first start in the lifecycle.state .initialized state by default to indicate the class has been loaded. From here, calling start method will change the state to lifecycle.state.starting. After successfully being started, the state is changed to lifecycle.state.started. When the stop is called, this goes into the lifecycle.state.stopping state. After successfully being stopped, this goes to the lifecycle.state.stopped state. In most circumstances, implementation classes should store their lifecycle.state in a volatile field and inside an atomic reference dependent on synchronization and concurrency requirements. In lifecycle 2, this extend the lifecycle interface. This interface should be merged with the super interface in 3.3 or 3.0. In the stop method, blocks until all tasks have been completed execution after a shutdown request or timeout occurs, or the current thread is interrupted, whichever happens first. Here you can see status of lifecycle in this is in enum lifecycle.state. The status of a lifecycle like a logger context here. Here you can see initializing object is in its initial state and not yet initialized but not yet started, starting in the process of starting, and started has started, stopping is in progress, and stopped has stopped. As an example, we can consider a the interface logger context. Anchor point for logging implementation. This is in package org.apache.login.log4j.spi. As an example 2, we can consider interface logger context. The logger context is the anchor for the logging system. It maintains a list of all the loggers requested by applications and a reference to the configuration. The configuration will contain the configured loggers, appenders, filters, etc., and will be automatically updated whenever a reconfigure occurs. This class in the different package, the package this interface in a different package. The package is org.apache.login.log4j.co. Here you can see reconfigure log4j using configuration builder with the configurator. Here an alternative to a custom configuration factory. This is to configure with the configurator. Once the configuration object has been constructed, it can be passed to one of the configurator.initialize methods to set up the log4j configuration. Using configurator in this manner allows an application control over when the log4j is initialized. However, should any logging be attempted before configuration.initialized is called, then the default configuration will be used for those log events. Here you can see class configurator initializes and configure the logging system. This class provides the several ways to construct a logger context using the location of the configuration file, a context name, and various optional parameters. Here you can see the method public static logger context initialize configuration. This initializes the logging context. This is the configuration here. This is in package org.apache.login.log4j.core.config. Here you can see a class log manager, the anchor point for the log4j logging system. The most common usage of this class is to obtain named logger. The method getLogger is provided as the most convenient way to obtain named logger based on the calling class name. This class also provides method for obtaining a named logger that use string.format string object style messages instead of the default type of parameterized messages. These are obtained through the getFormatter logger class family of methods. Other service provider methods are given through the getContext. Here we consider getContext and getFactory family of methods. These methods are not normally useful for typical usage of log4j. Here you can see public static logger context get context boolean. This is the current context. This returns a logger context. Here the parameter current context. If false, the current context appropriate for the caller of this method is returned. For example, in a web application, if the caller is the class in a web/lib webinfo/lib, then one logger context may be returned. And if the caller is a class in the container's class path, then different logger context may be returned. If true, then only a single logger context will be returned. This class is in org.apache.logging.log4j package. Here you can see in this example here you can see the method in logger context, the method public static logger context get context boolean current context. This returns logger context. Here the current context, if false, the logging context appropriate for the caller of this method is returned. For example, in a web application, if the caller is a class in web-info/lib, then one logger context may be returned, and if the caller is a class in a container's class path, then a different logger context may be returned. If true, then only a single logger context will be returned. Here you can see logging separation in web applications. This is using log4j 2 in web application. You can see these are context parameters here. Here log4j context name. If is log4j context selector named is true, log4j context name must be specified or display name must be specified in web.xml. Otherwise, application will fail to start with an exception. Log4j configuration should also be specified in this case and must be valid URL for the configuration file. However, this parameter is not required. By default, Log4j 2 uses servlet context name as the logger context name and uses the standard pattern for locating Log4j configuration file. There are 3 context parameters that you can use to control this behavior. First is Log4j context selector named. Specified whether the context should be selected using the GNDI context selector. If the Log4j context selector named is not specified or is anything other than true, it is assumed to be false. If here the Log4j context selector named is not true, the Log4j configuration may optionally be specified and must be a valid URL or path to a configuration file or started with class path to denote a configuration file that can be found on the class path. Without this parameter, Log4j will use the standard mechanisms for locating the configuration file. When specifying these context parameters, you must specify them in a deployment descriptor web.xml, even in a servlet 3.0 or newer application. If you add them to the servlet context within a listener, Log4j will initialize before the context parameters are available, and they will have no effect. Here with the JNDI context selector, note that this case you must also set the Log4j context selector system property to org.apache.login.log4j.core.selector.jndi context selector. For security reasons, from Log4j 2.17.0, JNDI must be enabled by setting system property log4j 2.enable JNDI context selector equal true. Here logging under logging separation, and then Java E in Java E application. This is the Java server pages logging, and this is asynchronous request and threads. The interface Log4j web support. This is specified an interface for setting and clearing thread bound logger context in a Java EE web application. Also defines constant for context parameter and attribute names. In most cases, you will never need to use this directly because the Log4j filter handles this task automatically. However, in asynchronous operations, you should wrap the code that execute in separate threads. With the set logger context and clear logger context. Here the method void set logger context sets the logger context so that code executing afterwards can easily and quickly access loggers via logmanager.setLogger. Here method void clear logger context clears the logger context set up in setLogger context, and this is in package org.apache.logging.log4j.web. This Log4j web support class. Sorry, Log4j web support interface. Log4j provides a simple mechanism for binding logger context to asynchronous threads. In some special circumstances, the simplest way to do is to wrap the runnable instance that is passed to the async.context start async context start method. Here you can, as an example 8, you can see asynchronous request and thread in Java server pages in Java to EE applications in logging separation. Here the interface Log4j web cycle. This is specified an interface for initializing and deinitializing Log4j in in Java EE web application. The default and only implementation is Log4j web initializer IMPL. The initializer is based on an interface to improve testability. The methods are contained in a package private and sub interface because general application code should not have access to them. This is in package org.apache.logging.log4j.web. Here the method void set logger context set the logger context to so that the code executing afterwards can easily and quickly access loggers via log manager get logger, and here void clear logger context method clears the logger context set up in set logger context. Now we are considering use cases. Standalone application in use cases in logging separation. Standalone applications are usually relatively simple. They typically have one bundled executable that requires only a single logging configuration. Now we are considering web applications. A typical web application will be packaged as a WAR file and will include all of its dependencies in web-inf/lib, and will have its configuration file located in the class path or in a location configured in web.xml. Now we are considering Java EE applications. A typical web application will be a Java EE application will consist of one or more WAR files and possible some EJBs, typically all packed in a EAR file. It is desirable to have single configuration that applies to all components in the EAR. The logging classes will generally be placed in a location shared across all the components, and the configuration needs to be shareable. Shared web application and REST service containers. In this scenario, there are multiple WAR files deployed in a single container. Each one of the applications should use the same logging configuration and share the same logging implementation across each of the web applications. When writing to files and streams, each of the applications should share them to avoid issues that can occur when multiple components try to write the same files through different web file objects, channels, etc. OSGI applications An OSGI container physically separates each jar file into its own class loader, thus enforcing modularity in jars as well as providing a standardized ways for jars to share code based on version numbers. Suffice to say, the OSGI framework is beyond scope of this presentation. There are some differences when using Log4j in OSGI container. By default, each jar bundle is scanned for its own Log4j configuration file. Similar to the web application paradigm, every bundle has its own LoggerContext. As this may be undesirable when a global Log4j configuration is wanted, then context selector should be overridden with basic context selector and JNDI context selector. Now we are considering the simple approach in approaches. The simplest approach for separating logging within application is to package each application into its own copy of Log4j and to use the basic context selector. Class basic context selector in package aug.apache.login.log4j.co.selector in module aug.apache.login.log4j.co returns either this thread context or the default logger context. While this works for standalone applications and may work for web application and possibly Java EE application, it does not work for all in the last case. However, when this approach does work, it should be used as it is ultimately simplest and most straightforward way of implementing logging. Now we are considering using context selectors. There are a few patterns for achieving a desired state of logging separation using context selectors. Place the logging jars in a container class path and set the system property log4j 2.context selector org.apache.login.log4j.co.selector.basic context selector. This will create a single logger context using a single configuration that will be shared across all applications. Place the logging jars in a container's class path and use the default class loader context selector. This is step 2. Follow the instruction to initialize the log4j 2 in a web application. Each application can be configured to share the same configuration used at the container and can be individually configured. If status logging is set to debug in the configuration, there will be output from the logging is initialized in the container and then again in each web application. Step 3, follow the instructions to initialize log4j 2 in a web application and set the system property of servlet context parameter log4j 2.context selector to org.apache.login.log4j.co.selector.jndi context selector. This will cause the container to use JNDI to locate each web application's logger context. Be sure to set the is log4j context selector named context parameter to true and also set the log4j context name and log4j configuration context parameters. JNDI, the JNDI context selector will not work unless the log4j 2.enable JNDI equal true is set as the system property or environment variable. The exact method for setting the system properties depends on the container. For Tomcat, edit $catalina_home/conf/catalina.properties. Consult the documentation for other web containers. Now we are considering logger context factory in extending log4j 3. Application may change the LoggerContext factory that will be used by here, and the interface LoggerContext factory in package org.apache.login.log4j.spi in module org.apache.login.log4j implemented by factories that create LoggerContext objects. The application may change the LoggerContext factory that will be used by create a binding to the logging information, implement a new LoggerContext factory, implement a class that extend org.apache.login.spi.provider with no with a no arg constructor that calls a superclass constructor with priority the API versions, LoggerContext factory class, and optionally thread context map implementation class. Create the meta dash info inf /services /org.apache.login.spi.provider file that contains the name of the class that implement org.apache.login.spi.provider. Setting the system property log4j2.LoggerContext factory to the name of the LoggerContext factory class use. Setting the property log4j2.LoggerContext factory in a properties file name log4j2.logmanager.properties to the name of the LoggerContext factory class to use. The properties file must be on the class path. The LoggerContext factory bind the Log4j API to its implementation. The Log4j log manager locates the LoggerContext factory by using java.util.service loader to locate all instances of org.apache.login.log4j.spi.provider. Each implementation must provide a class that extend org.apache.login.log4j.spi.provider and should have no arg constructor that delegates to provider constructors passing the priority. The API versions it is compatible with the class that implements org.apache.login.log4j.spi.LoggerContext factory. Log4j will compare the current API version, and if it is compatible, the implementation will be added to the list of providers. The API version in the org.apache.login.log4j.logmanager is only changed when a feature is added to the API that implementations need to be aware of. If more than one valid implementation is located, the value for priority will be used to identify the factory with the highest priority. Finally, the class that implements org.apache.login.log4j.spi.LoggerContext factory will be instantiated and bound to the log manager. The log4j2, this is provided by log4j context factory. The application may change the LoggerContext factory that will be used with this. Now we are considering context selectors. Log4j provides 5 context selectors. The interface context selector in package org.apache.login.log4j.core.selector in module org.apache.login.log4j.core. Interface used to locate a LoggerContext. The Log4j provides 5 context selectors. Basic context selector uses either a LoggerContext that has been stored in a thread local or a common LoggerContext. Class loader context selector associate LoggerContext with the class loader that created a caller of the getLogger call. This is the default context selector. JNDI context selector locates the LoggerContext by querying JNDI. Please see log4j.allowed JNDI protocols, log4j to allowed JNDI protocol, log4j to allowed LDAP classes, and log4j to allowed LDAP host for restrictions on using JNDI with log4j. Async LoggerContext selector create a LoggerContext that ensures that all loggers are async loggers. Bundle context selector associate LoggerContext with the class loader of the bundle that created the caller of the getLogger call. This is enabled by default OSGI environment. Context selectors are called by Log4j LoggerContext factory. They perform the actual work of locating or creating a logger context, which is the anchor for loggers and their log configuration. Context selectors are free to implement any mechanisms they desire to manage logger context. The default Log4j context factory check for the presence of injector binding for a context selector. If none are defined, the system property named Log4j context selector is checked. If found, the property is expected to contain the name of the class that implement the context selector to be used. This class is then used for creating context selector instances. Log4j provides five context selectors. Now we are considering context parameters. In a web application, here set the logging context name to my application. By default, the Log4j2 uses servlet context name as the logger context name and uses the standard pattern for locating Log4j configuration file. There are three context parameters that you can use to control this behavior. The first is Log4j context selector named, specifies whether the context should be selected using JNDA context selector. If the Log4j context selector named is not specified or is anything other than true, it is assumed to be false. Here you can see set the logging context name to my application. Here set the configuration path file. Configuration path / file / URI to etc /myapp / mylogging.xml. Here they use the JNDI context selector. Note that in this case you must also set the Log4j context selector system property to org.apache.login.log4j.code.selector.jndi context selector. Exception example, we can consider null point exception. If the specified name is null in the method public void set name string name in class logger context in package org.apache.login.log4j.co. As another exception example, we can consider this occurred in the Apache in the environment with Apache Log4j 2.0.2. The null point exception in thread main java.lang.exception in initialize error caused by java.lang.class cast exception. org.apache.logging.slf4j LoggerContext cannot be cast to org.apache.logging.log4j core.loggerContext, etc. Now this is the end of my presentation. Thank you very much for watching it.